Okay, in this video we're going to talk about inequalities. This is going to pop up in 3 or 4 different types of questions that we do in algebra. So I'm just doing really straightforward ones here because students often struggle to answer questions like this. So here, imagine we were asked to find the range of values for which x squared plus 7x plus 12 is greater than or equal to 0. So if you have a quadratic and you're looking for it greater than or equal to 0, the first thing that you want to do is you want to sketch a graph. You want to sketch this quadratic. Before I can sketch a quadratic, I need to identify where are the roots of this quadratic. Where does this quadratic cross the x-axis? So if in a number of different questions we do over the next few videos, you're going to end up with a situation like this. And what I want to do in order to answer this question is I want to actually solve it. So I'm going to ignore the inequality for the moment. I'm going to let it equal to 0 so that I can find the roots and I can draw myself a little sketch of my graph. If you have x squared plus 7x plus 12, if you factorize that, you're going to get x plus 4 times x plus 3 equals 0. And you're going to let each one of your factors equal to 0. So you're going to let x plus 4 equal to 0 and x plus 3 equal to 0. You're going to end up with x equals minus 4 and x equals minus 3. Now, the only reason that I've actually drawn any of this is so that I can draw a rough sketch of my quadratic. Remember that if you have a plus x squared, then that means that your quadratic is a U-shape. And I know that when I solve a quadratic, if I let it equal to 0, factorize and solve it, I identify the roots. And the roots are the points where the quadratic crosses the x-axis. So again, your graph doesn't need to be accurate, it just needs to be rough. So I'm saying that roughly, this is a U-shaped graph that crosses the x-axis at minus 4 and then also crosses the x-axis at minus 3. So this is my quadratic. Now that I have a sketch of my graph, I'm going to be able to answer this question. The question here is, when is this quadratic greater than or equal to 0? Greater than or equal to 0 implies above the x-axis. I want to know, when is this quadratic above the x-axis? Clearly the quadratic is above the x-axis in this region and in this region. So that's 2 separate regions, which means that I'm going to get 2 separate answers. If I take x values that are to the left of minus 4, in other words minus 5, minus 6, minus 7, anything smaller than minus 4, the quadratic is above the x-axis. So my first answer is that when x is less than or equal to minus 4, so when x is to the left of minus 4, the quadratic is above the x-axis. That's my first region. When x is less than or equal to minus 4, I know that the quadratic is greater than or equal to 0, or in other words, above the x-axis. Now, to describe this region, we're talking about all of the x values to the right of minus 3. Like, for example, minus 2, minus 1, 0, the whole way up. Values that are bigger than minus 3. So the second region for which the quadratic is above the x-axis is when x is greater than or equal to minus 3. So we're going to come across this a lot, and usually this is the last couple of lines of a question. And I find that a lot of students struggle to identify their inequalities. Now I want you to think about something else. Imagine if I change the question now. Imagine if I just change the inequality. Imagine if I flipped it the other way around and I asked you, when is the quadratic less than or equal to 0? It's less than or equal to 0 when it's below the x-axis. So in this case, it's less than or equal to 0 in this region. I want you to notice that in this case, that's only one region, which means we would only give one answer. The quadratic is below the x-axis when the x values are between minus 4 and minus 3. Or in other words, when the x value is greater than or equal to minus 4 and when it's less than or equal to minus 3. If it's greater than minus 4 and less than minus 3, it's somewhere in the middle and the quadratic is below the x-axis, or in other words, the quadratic is less than or equal to 0. So in this video, I'm just going to give you a few quadratics, sometimes greater than or equal to, sometimes less than or equal to, and I want you to see if you can answer it the same way as I've done this. Okay, so to practice this material, I want you to find the range of values of x for which each of these statements is true. The first one, you have a quadratic. I want you to tell me, when is the quadratic less than or equal to 0? The second one is the same, except I'm just changing the inequality. The third one, I have minus x squared minus 2x plus 15 is less than 0. And the fourth one, it's greater than 0. So in each case, you let the quadratic equal to 0, you factorize and solve it, sketch your graph, and then look towards your inequality and identify the regions that you're looking for. So I want you to pause the video now and then come up with your own solutions and compare them to mine. Okay, so the first question you had here was x squared minus 18x plus 45 is less than or equal to 0. In order to identify when this quadratic is less than or equal to 0, I need to sketch the quadratic. And in order to sketch the quadratic, I need to find the roots. So I let the quadratic equal to 0, I factorize it and solve it, and I find that the points for this quadratic crosses the x-axis are x equals 15 and x equals 3. So it's a plus x squared, so I know it's a U-shape, and I know it crosses at 3 and at 15, so it looks something like that. Again, there are no marks going for the graph, so I literally just sketch it. It doesn't need to be accurate. I want to now know, when is this quadratic less than or equal to 0? The quadratic is less than or equal to 0 when it's below the x-axis. Clearly, I'm referring to the region where x is between 3 and 15. So my x value, it needs to be greater than or equal to 3. It needs to be less than or equal to 15. If I take an x value between 3 and 15, the quadratic is below the x-axis. I want you to notice there that because there's an equal to sign in the question, I have an equal to sign in my answer. If there was no equal to sign in the question, I wouldn't have an equal to in the answer. That's the only difference it would have. But in this case it does, so my final answer is that x is greater than or equal to 3 and less than or equal to 15. The second part of the question was exactly the same, except I just swapped the quadratic. I now want you to tell me, when is the quadratic greater than or equal to 0? So once again, you'd sketch your quadratic, but the quadratic is greater than or equal to 0 when it's above the x-axis. Notice that this time it's two separate regions. If it's two separate regions, then I need to get two separate answers. One of them is when x is less than 3. If x is less than 3, then the quadratic is above the x-axis. So my first answer is x is less than or equal to 3. But then I notice that if I take an x value bigger than 15, then the quadratic is also above the x-axis. So what if I took an x value greater than or equal to 15? If x is greater than or equal to 15, the quadratic is also greater than or equal to 0. So in that case, you have two separate answers, which you cannot write it as one region, because it's impossible for x to be both less than 3 and also greater than 15. So you have to write them as two separate answers. Okay, the third one I asked you to do was minus x squared minus 2x plus 15 is less than 0. In order to figure this one out, I'm going to need to sketch a quadratic. So what I decided to do was to let the quadratic equal to 0. And I'd advise you not to factorize it with a minus in front of the x squared. So I multiplied everything by minus 1, and I got x squared plus 2x minus 15. I factorized and solved it, and I found that the roots were x equals minus 5 and x equals 3. Now this is a minus x squared, which I remember from junior cert, that means that it's an N shape. So it looks a little bit like this. Crosses the x-axis at minus 5 and the x-axis at 3. This question is asking me, when is the quadratic less than 0? It's less than 0 when it's below the x-axis. So in other words, this region to the left of minus 5 and this region to the right of 3. If I'm looking for the values to the left of minus 5, I'm referring to x values that are less than minus 5. So in this case, my first answer would be when x is less than minus 5. I'm not using less than or equal to in this case because there's no equal to in the original question. If I take an x value that's smaller than minus 5, like out here somewhere, clearly the quadratic will be below the x-axis. On the other hand, if I take an x value that is bigger than 3, or in other words, when x is greater than 3, out here someplace, the quadratic would also be below the x-axis. So that's the answer to part 3. Part 4 now is just the opposite of that. So part 4, I was asked, when is the quadratic greater than 0? And I've already sketched my graph, so the quadratic is greater than 0 in between x is minus 5 and x equals 3. Clearly any x value that I take between here and here, the quadratic will be above the x-axis. This is one region, so I can just give it as one answer. The answer in this case is that when x is greater than minus 5 and when x is less than 3. Once again, I'm not using an equal to sign because there's no equal to in the original question. But in this case, just take note again that it's one region, so it's only one answer, whereas in part 3 we had two separate regions, so it was two separate answers.